So, hello everybody, my name's Tom Kirkham. I'm a computer scientist. I did a PhD a while ago in distributed computing, and I'm on different projects and things since then. I've got an interest in distributed models, computational models and model sharing and data associated with that. And I've been working on the DAFNI project now for just about 18 months, having worked on various other research projects in the period at Innovate UK as well before that. So my role at DAFNI is science lead, so I work across different projects within the facility. And DAFNI stands for the Data and Analytics Facility for National Infrastructure. And DAFNI came about initially from a £8 million investment around 2017 from the UK Collaboratorium for Research on Infrastructure in Cities, which is a group across different universities which provide a lot of physical built infrastructure experiments, but also virtual as well. When that was set up, they were requiring some sort of neutral point for model and data sharing for that infrastructure, and that's where we come in. So we provide a compute platform to support research into decision making around national infrastructure, and that decision making is effectively made by using data and computational models combined. Since 2017, DAFNI has developed into a few different directions. We've got funding from a few different sources, UK government research grants, but also European grants and direct government funding as well. So some of the work we'll touch on later sort of covers some of those areas, and we branch across industry and academia and policy making as well. So DAFNI, in a nutshell, from a technical perspective, we're a secure repository for various types of computational models related to national infrastructure. And what we mean by computational models in simple terms basically could be an algorithm which basically processes data to do X. We try and contain as much data as possible on the platform as well, because the whole idea of DAFNI is that it's a collaborative point in which researchers can come together to basically work with existing data and work with existing models to try and improve or develop new processes or upload new data and models to basically help collaboration on specific research challenges. We'll go into that in a bit more detail later on. But underpinning DAFNI is a high throughput computing platform. So, some people come onto DAFNI and use it for the compute as well. And another key point about DAFNI as well is that we're at a point in which your data and models from your research can be effectively put onto the platform and archived for long-term accessibility, and that can mean you can refer to it later on in maybe other projects that you start up, but also it's a point in which other people, if you make it public, can discover your research and contact you to basically try and resurrect things or collaborate and continue things onwards. So the DAFNI team's grown over the years, and we've got quite a diverse bunch of people working for us. We've got obviously a lot of technical people, got quite a lot of people focused on software within that team, but also data. We've got a specific user liaison team, which Kyle leads, who's going to be talking later on and giving a demo. We've also got platform DevOps management teams, but also people who cover things like data science, data curation, and also we've got program management and community engagement as well as part of the DAFNI program. DAFNI, we're hosted at the Science and Technology Facilities Council. This is the reason why we were sort of chosen as part of the UK CRIC work. We're effectively hosted at a government laboratory down in Harwell in Oxfordshire. The Science and Technology Facilities Council, if you're not familiar, is part of United Kingdom Research and Innovation, UKRI, and we're a research council alongside the likes of EPSRC, BBSRC, etc. So effectively, most of our money comes from DSIT, and they distribute it to STFC to fund people who want to come onto our sites and use our scientific facilities. So if you look at the picture on the top left, that's Rutherford Appleton Laboratory, and you can see the big circle at the top there. That's the Diamond Light Source, which is an electron accelerator about the size of a football stadium. We've also got lasers on site and neutron accelerators as well. And our compute at Rutherford supports all that scientific research, and we also are a tier 1 site for CERN. So we're not a university, and we're not industry. We're sort of more government supported, so we sit in that sort of channel between. We've also got a site up at Daresbury near Warrington, where the Hartree Centre is located, who do a lot of applied research into industry. A lot of that is around data analytics, the hype technologies around AI and things like that. And over on that site, we host a dedicated data centre for applied research where industry and academia can collaborate. And then finally, our other major site is up in Edinburgh at the Astronomy Technical Centre, up on the hill there, where we do a lot of our hardware development for telescopes and things like that. So going back to DAFNI, the basic platform consists of sort of three main elements that we sort of summarise as the National Infrastructure Modelling Service, the National Infrastructure Database, and the National Infrastructure Visualization Suite. These technologies sit effectively on Kubernetes, which is more or less a cloud-based platform where we handle Docker containers. We use Docker containers because that enables us we support researchers using the Docker containers. So if you've not got any experience with Docker, it's not a problem. But Docker enables us to basically package models within their sort of execution environment and archive them on the platform. So you don't need to worry about updates and things like that to the libraries that your models use. And also you don't need to worry about setting up the appropriate environments. If you're not familiar with the model that's maybe from a third party, you can access it and use it using Docker as packaged. The basic flow within DAFNI is that basically you go onto dafni.ac.uk, where you're presented with a login page. If you're an academic, you can just log on using your federated ID, and the platform is free to use. If you're industry or government, you can get access to, but you just have to register, and we'll get back to you pretty quickly with the appropriate credentials. When you're logged onto the platform, you can start to explore the different services that we present. So you can look and explore the data repositories, or you could upload and add to the data repositories too. And the same applies to the models as well, which are contained in Docker. The point at where these models and data combine is within the workflows, which we present on the platform, which is in a graphical modeling service. So you can basically select models, select data, drag them together, chain them together to get different outputs. And then the final part is the visualizations, which you can generate as a result of the outputs from the workflows. So if you're curious to look at DAFNI, you can log on to DAFNI, explore a few different workflows, run them, maybe move a few different models around, put some new data on, maybe some additional processing, and start like that. So for researchers who are looking to get a head start, instead of starting from scratch, it's a good place where people can look at existing work and build ideas up. If you're, say, a policymaker, we have policymakers using the platform. They can engage with universities who have done research, run their models on DAFNI, and work with them to understand and improve them for their specific policy goals. So this is just a quick, more detailed look at the data catalogues that we host. So you can search by different themes, different technologies and projects which have supported them. We've got a pretty wide ranging set of data on the platform at the moment, and the same applies to models as well. So you can look through the model repository to find models from various different domains. You can see what the date is when they're published and who manages them. If you upload data in the models to the platform, you don't have to make it public by default. You can make it private, so you can restrict it to a specific team that you're collaborating on if your research is not ready to be made public. But if you do make your research public, the models will be linked to your institution. So if people want to get more information from them, they can contact you directly. And here's a closer up view of how we've sort of chained the workflows together, so you can see the different steps right there. So our main visualization tool that we use is Jupyter Notebooks, but you can also pipe data out into other visualization platforms as well on DAFNI. So here's some examples with how DAFNI is being used. So one of our European projects is specifically looking at air quality. There's different use cases associated with that, such as a lot of them are based around cities, so there is some coastal cities in there. So I think we're looking at Bergen in Norway, where cruise ships can often pull up, leave their engines running, and the pollution rolls down the valley. We model different weather conditions and factors like that to try and determine air quality and try and influence policy around city policy to try and reduce the impact of air pollution. We've done projects using sort of going into the digital twin domain. So this one's specifically around Sheffield, trying to replicate traffic flows and trying to identify where congestion would occur. We've done a large amount of work on a project called Open Climate. Here we've got flooding, a lot of flooding models, particularly coastal flooding, and trying to identify hazards, risks and mitigations. And we've also done work in that vein on the project called Credo. So Credo is a resilience demonstrator working with the Connected Places Catapult and some water companies, where we're looking at the impact of flooding. Sorry, apologies. I'll get rid of that because it seems to be taking itself off automatically. But yeah, the Credo project, we're looking at what happens if there's flooding in a specific location and how it can impact other elements of national infrastructure. So I think there's been cases where floods have gone into substations, taken the power off, which can then impact the telecommunications network, take down the telecoms towers, and there can be knock-on effects therefore on different assets. So Credo's looking at developing risk-based models to try and determine the impact of potential events, but also what mitigations and adaptations can be applied to try and reduce that risk. So Open Climate, lots of modelling and simulation and identifying assets, leading into risk. Credo specifically looking at risk and how adaptation can be used in those scenarios. Through UKRI, we've got funding for BSRW, which is Building Secure Resilient World-Specific Projects on DAFNI. So we've got quite a diverse sets of data and models associated with this work on the platform. So we've got, for example, a lot of water, again, modelling data and models associated with flooding, such as a lot from the University of Newcastle. We've also looked at sort of impacts on things like buried infrastructure. So the Storms project at the University of Birmingham is looking at trying to identify with organisations like Cadent what pipelines and what infrastructure is the most sensitive to disruption, whether it be flooding or other events in the sort of buried infrastructure area. And that links in nicely with the National Underground Asset Register work that's being done through DSIT, where they build a national repository of underground data. Other sandpit projects include a lot around transport, so the impact of climate on transport and the resilience of railway networks applies to roads and airports as well. And we're also looking at energy, so for instance, the DRES project's looking at grid resilience in relation to the potential of using batteries from EVs during extreme weather events and trying to model that. And again, a lot of this work is around risk and lots of risk models on the platform. So from a sort of climate adaptation coastal perspective, we've got risk models that can be reused, but also quite a lot of hydrological models and other sort of infrastructure related modeling and risk that can be associated with the coast. And feel free to go onto DAFNI and have a look at what models and data's on there. Please get back to us if you have any trouble. We'd be more than happy to introduce you to the people who develop those models and data and trying to expand your network as well. So in summary, DAFNI is a place where people can collaborate around models and data into workflows. We've got lots of models and data sets on the platform, and it's free to use for academics and also government and industry. To give a little bit more overview of the platform, I'll now hand over to Kyle, who will do a demo. So I'll stop sharing.
Thank
Kyle,
you.
are you okay to start? Thank you.
Yeah. Are we doing questions first, or should I go ahead and then we'll do questions after? Or would you prefer to run this?
Yeah, let's do the demo, and then we can do questions after, and we'll go back to the different bits if we need to.
Okay, sounds good. Right, so basically I'm going to follow on from Tom there and show you how DAFNI actually works in practice and take you through a sort of mini tour of it. Probably will be quite mini because it's I don't have a huge amount of time. Okay, so first of all, I'm going to share the screen. Okay, so first things first. See, so this is what you come to if you go to the DAFNI homepage. So you can get that straight away from just typing in www.dafni.ac.uk, or you can Google for DAFNI and not go to the hair products version, because there's two DAFNIs apparently, and one makes hair dryers and things. That's not us. Okay, so first thing you want to do is, if you don't have an account already, you can click in My DAFNI here, this side in the top right hand corner. And you can see you can sign in straight away, and you can also register. So it's a fairly straightforward procedure to register. We have two types of accounts which you can apply for clicking on the button there. A basic account, which you should get very fast. If you apply for that one, you'll get pretty much immediate access to our data catalogue, the public part of our data catalogue, because there's two parts to that. And also details of models and workflows. The expert account gives you basically more flexibility to upload models, upload your own data sets, and also to run jobs using CPU and DAFNI. So essentially, that's all you need right there for getting an account. And if you're a UK academic, getting an expert account should be very straightforward. Okay, so assuming you already have an account, we can go straight ahead and log in. And I'm going to use Keeper to launch my own account and give you a brief tour of DAFNI and the front end. Okay, so this is what you'll see if you log in. And if you're on an expert user's account, you should have access to absolutely everything there. So these correspond to the different components of DAFNI that Tom mentioned. So the NID is the National Infrastructure Database, and that gives you access to all the data sets we have here. And you can see a couple of outputs. So I was just trying out one of our models from the sandpits before we came online. Okay, and you can see all sorts of data in there. And this will just be the publicly available data that you see here. And these 142 sets, which are publicly available, and you've got full metadata describing these to help you find them as well. Likewise, we can navigate using left bar. You can also see the models which are available. And again, this isn't the complete catalog. These are the models that are public or owned by this account specifically. And we'll come back to that later. Workflows, essentially, they take models and run them. And again, I can show you how that works later, but essentially if we go to a straightforward one, say this is a water catchment model. I think this is one that's, yep, this is an Imperial College model. And if we go in here, you can see straight away, it just straight in runs a model and then collects the data at the end. So that's a straightforward model in terms of workflow. What goes on inside the actual model SIP is more complicated, obviously. Okay, so those are and that basically both the models and the workflows are handled by the NIMS and DAFNI, and it deals with all the metadata as well, and all the storage of these models and workflows within the DAFNI system. Visualizations is exactly what it says in the tin. If you want graphs, you can come in here to a visualization, and you can create these visualizations from data stored within DAFNI. Okay, so that's a very quick whistle-stop tour. I'll briefly describe what these are at the end, but I think, first of all, we can go in here. Now, if you have an expert account, and I'm going to do this very quickly. In fact, I might just blue Peter it a bit and show you one I've made earlier. You can basically upload any data you want. This is not something available in the basic account. I should point out that the expert accounts, you do need to go through a verification process. It should be fairly straightforward for UK academics. So, okay, so I'm just going to quickly browse through here, upload a file. And this, I believe, is basically just a JSON file containing details of all the ships that were sunk by U-boats in World War II. And I use this because it sort of clips in neatly to our demo visualization. Okay, so we have a title. And it's the first of the bits of metadata. There is quite a lot to go through in the metadata, but this is basically to provide a rich array of metadata so that it can be found easily later on. So it's certainly an essential part of doing this. Okay, and you then select a category. I think I'm just going to put transport networks. I think it's maybe one that's more appropriate, but goodness, I can't see it at the moment. Got the language and various keywords as well. I'm just going to very quickly do this because it's a demo. Okay, and you can then pick a region. This is absolutely everywhere this data refers to. So I'm going to pick Earth. So bounding box for everything. And the data does have dates, but I can't remember the dates at which the war started and ended off the top of my head. So I'm just going to put no dates there. But you can, if you did know, you could sort of pick your dates in here. It's probably sometime around 1939. So, yep, and then you could pick an end date as well. But we're going to do the quick route and short circuit it and say it's got no dates. Organization name. Again, this is your organization. Date it was created, which we're going to set to today. And yeah, we've got our name and address. You would also put in your license, which is very important. Sometimes people forget about the license, but it basically uses, basically creates a license for you, which you'll need definitely to protect your data. And I'm going to keep everything else the same, and I'm going to publish this. So, goodness, right? Oh, we forgot the subject. Okay, and hopefully there's no more red bars. And hopefully this goes nice and fast. Okay, there we go. Nice, okay. Goodness, I was worried that would take a few minutes there, but it didn't. Okay, so this just means it's moving around internally within DAFNI, being copied to the correct area where we store our data. Usually it comes in pretty fast for smaller data sets, but we can go ahead and use a visualization in other ones. Got the same set from earlier on. So we want to actually now come and look at the data and graph it so we can create visualization. We've got two different types. We've got one that looks primarily at CSV files. There's a drag and drop interface, and we've also got the more flexible version as well, which is essentially Jupyter notebooks. So you can write scripts in basically in Python or R, which is a good statistical language. Python's better for general graphing. Okay, so and I think that went really fast, and we can grab that hopefully. That's the data set we just created. So I don't actually need to search for one, but if I wanted to, you could search, and there's probably a couple from earlier. Yep, but we're going to stick to the one we just uploaded. We can pick a Jupyter notebook for extra flexibility. And ships, we're going to, obviously, if you were doing this for real, you'd write a lot more and you wouldn't cut and paste into the description. But in this case, for speed, we'll do it this way. And we can create one of these. And off it goes. So it takes a little while to start up. So I'm going to look for one that's, yep, that I put in before lunch so that we don't need to wait on it starting up. You can see the data is automatically carted in from DAFNI. We can see various items here. These are all individual instances of a ship that was basically sunk by a submarine in World War II. And if we go in here, this is kind of quite standard Python. You can see we're plotting various things like the tonnage of the ships that were sunk. We've got a nice graph there to show like how things were progressing as we went through the years. And I'll have to rerun this bit because it's using interactive Python and never kind of carts over from the old instance of the notebook. But yeah, so this should be clickable. And this is just a demo to show you what the sort of things you can do with the Jupyter notebooks we've got in DAFNI. So basically, if the data's in DAFNI, you can take it through straightforwardly into a Jupyter notebook in our visualizations. Okay, and these are all in our GitHub as well. So if you go to our GitHub, which should hopefully pop up if I type it, yeah. So yeah, DAFNI example models, and you can find that there. Along with there's lots of other ones as well. So we've got some pretty straightforward ones, some simple AI examples, solar energy example, various bits and pieces, and something in C++ and Fortran as well. Okay, so that essentially is our visualizations. We also have there's some other visualizations as well. So this one is in progress. I'm going to just run the one from the OMC Council site, but we also have this too in DAFNI, and this is part of another EU project called Cross EU, which is a cross-disciplinary project which looks at climate change throughout Europe and how it impacts in various regions. And the idea is to develop into a tool which will give policy advice to people looking to how to deal with that in the future. So we already have one of our scenarios in DAFNI already. This is a straightforward one to show you basically how climate change progresses in Europe over time. You can see here. Select our dates, and unfortunately I've got too many tabs open, so it's not responding very well. But yeah, it's a lot faster when you don't have like 60 tabs. I've got another instance of the browser which has more tabs, which is what's causing that. Also, there we have another one. So this is part of a project. We don't actually have the viewer itself in DAFNI, but we do have all the data with this as well. And I have pre-focused it in coastal flooding, as I felt would be the most interest to people here. And this projects forward in time. This was from a project carried out by Oxford University on climate change risks for the future and calculators. And this is the idea of this was essentially to apply it to pricing in the cost of climate change in various assets. Factory sites, for example, would be a very obvious one, and fuel networks as well. And you can get all sorts of stuff in here as well. River flooding, projected river flooding, and you can change the frequency as well. So that's the time in between expected events of these scales. And as I mentioned, all the data is in DAFNI as well, which you can look at. Not all of it's public yet, but it will be very soon. I think all of Europe's on there at the moment. Okay, so if we go back, now the models themselves, I'm going to show you one of them, which we can use as an example, is from the Mars project. And essentially, this was one of our sandpit projects for building a safe and resilient world. And this one essentially is asking what happens if we shut down airports. If something happens which closes down an airport, and we look for viable alternatives. Essentially, it remaps all the planes that are in the air and having their original flight plans cancelled. So it takes into account all sorts of things, how busy the runways are, what else is in the airspace, and also what's happening at all the various airports and the contracts that the companies have signed with the airports for diversions. So it ends up being quite complicated. Mostly, a lot of it is due to the sort of the juggling about with the airports and the contracts. So this would be, again, these are uploaded. These are all Dockerized, these models. The idea being the model remains the same over time. And we don't actually run the models directly as such. These are embedded into workflows, which I showed you earlier. For this one, for example, this is another one where it essentially runs one piece of code and then collects the data at the end. And you can see that there. And it's very straightforward to run these. What we do is we just go into the workflows, navigate to the model, and you can see this has already been run twice, but say we want to run it, the Birmingham scenario has not been done. So if we can execute that. Click OK, and there we go, it's off, it's started running now. And actually it should only take a couple of minutes, this one, but oh, I'm not going to wait. So we can go in there and you can see it's off running and preparing the data. This is all the data and the flights that's contained in there. Okay, and we can go to the output for this. In fact, we can go directly from the workflow itself. And I should point out this is running in DAFNI's hardware, so it'll either be running in the STFC cloud or one of our own computational nodes. So if we go in here and have a look at the ones from earlier, you can click there and go directly to that visualization. And I think this one should probably be the one that's diverting from Manchester. It'll either be Manchester or one of the London airports, yeah. And there we can see that pops up a visualization and we can see all the various diversions that have taken place. How many flights have been affected. You can see like even just 3 hours after lunchtime, there's an awful lot of flights get diverted. And that essentially shows how we would run a model in DAFNI from start to end. Okay, so we also have the command line interface. So a lot of what I've done, you can also do via the command line if you want, and put it into scripts, for example. And it's very simple to install. It's just a Python package. And then you can come through here to see the the documentation. So it gives you some basic documentation. So essentially, once you've got your account, you can log in. And for example, if you type in DAFNI get data sets, it'll automatically run through and find all the data sets. You can output them in JSON for further parsing as well, for example. Okay, and if you've got Python installed, that should be really simple to do. Okay, so I think, yeah, but that was just the examples. One thing that might be of interest as well is the firm project. So that Tom covered that, but you can also search for it as well. And I think if you Google Newcastle firm 2, you should find the code, the underlying code, which has been uploaded onto DAFNI in a full description. And you can also find a link from there and see a description and a talk on the project as well. It's essentially an agent-based evacuation from coastal flooding events after extreme weather. Okay, so I think that concludes.
Thanks very much, Kyle. So yeah, I guess the platform is relatively straightforward to use, but if you get stuck into it, you need any support or anything like that, we're here to help. We've also got lots of YouTube videos and documentation as well to support new users on the platform. I guess, Stuart, we'll move on to questions now, if that's okay.
Yeah, no, yeah, very happy for people to add questions to the Q&A or into the chat. Just before I sort of read anything from anyone else, I mean, it's obviously really powerful. I mean, and I was really intrigued by that when you showed the GRI risk viewer and the sort of coastal flooding. That's something of real interest to people here. So just thinking about that, is it possible through the DAFNI network to link something like that, so the flood risk mapping, to say community information, and is that type of information available on DAFNI, like about communities? So say, for example, you know, the number of people living or the number of households, could you sort of intersect those different data sets? Is that the sort of thing we can do with DAFNI?
There's always a kind of tension with that sort of thing. And there's certainly this, I suppose it's what you're talking about is the example of where you can turn two fairly innocuous sets of data or multiple sets of data into something that's not innocuous, something that can be used in such a manner. We do have a system where data can be private or secured, and for very secure information, we wouldn't store it in a regular fashion in our servers.
No, okay. But would you be able to have, I mean, can you in some sense bring that type of data together? Is that's the sort of things people could look at to look at where the risks are and how that affects, because obviously the sort of coastal projects, strongly related to how communities might be impacted by coastal change. So looking at those things and understanding where people are perhaps impacted might be something that's really useful for modeling like this. Yeah.
I mean, a lot of the data is open. We do have examples of data that isn't open, but that is secured. Sometimes in separate secure servers. So like the Credo project's an example of that. It contains all sorts of information about the infrastructure of various regions, power networks, and so on.
And the flooding network data is on the platform you mentioned, Kyle. So if people upload community data, they could probably start linking the two together.
That's really interesting. One comment about I suppose you touched on it there almost. There's one question there in the chat about whether or not how that data could be misused, but I guess you sort of spoke something about that in terms of what's available or protected and what have you. Thinking about that, what was the sort of the main outputs then that have come from using DAFNI, perhaps?
So I'd say actually the models themselves and open use of the models is something that's a main output, as well as the case studies. Tom?
Yeah, it's more sort of open collaborative research, bringing people together to look at policy or other impacts. We have looked at data which is sensitive. So I mentioned the NUAR data, the National Underground Asset Register data. It's separate to DAFNI, but their data identifies where all the water and the gas pipes are under the pavement. So if somebody knew those locations and wanted to cause a bit of disruption, it'd be pretty handy for them. And that data originally was going to be made open, but it's with the OS, and I think you need specific permissions to use it. But in order to get real value from that kind of data, it needs to be opened up more. So we're interested in that kind of challenge in DAFNI, but it breaches onto this trusted research environment type of area, like DARE UK and that kind of research. It's a definite interesting area for us. Our Credo work does contain that kind of sensitive information, and we've got a separate security architecture for that. But at the moment, like Kyle says, a lot of the data, if it's sensitive, we just keep it private or within a specific team.
Yeah, that makes sense. Yeah. So yeah, and we've posted up some of the example about sort of coastal flooding, and I think that's really interesting. I was just looking, sort of following on from your link of the GRI risk viewer. Can you tell us something about how does that type of modelling work in DAFNI? So what's the sort of input data that you put into that, and how does it come up with that model? Because it's quite complex, I think, as many of us probably here know, to work out what coastal flooding risks actually are. So I don't know whether you can give any. Can you give any sort of explanation how, or is that somebody? Yeah, is that sort of specific to a certain project? How that's worked out?
For the risk viewer, that's Oxford University's work. So that was carried out by our collaborators at the university. So I'm afraid I don't know how they calculated the flood risks. They used RCP scenarios,
right?
To do it, but
they're mapping those on presumably to coastal topography to look at where. Yeah. Sorry.
Oh, I was going to say, the contact details are actually on there. I'll post the link.
Yeah. No, I think that would be useful to people particularly to look at that coastal flooding thing, and understand. Yeah, I mean, it certainly looks very interesting. What's there?
Okay, so that's trying to find the link there. Okay, so so there's the app itself.
Yeah, that's great. I think we can see that message in the chat. So, yeah, I think what's really interesting is it's obviously really easy for people to log into and get access to the DAFNI environment. What do you think? What do you think are the things that people need to be aware of in terms of the hurdles of getting onto the system? So you gave it quite a neat sort of explanation of there, but in terms of what, before you started some work on it, what would you need to think about, what you were looking for to find? I think you gave a good explanation. You could take data sources from lots of different places. If I was going to go and use this and understand something about flood risk, what would I need to think about in terms of the data I was looking for and what I would find on DAFNI, or what I might need to have to bring? Would I have to bring something to DAFNI in order to make something work? Does that make sense? Yeah.
Yes. Yeah. It really depends what you want to bring in the platform and what you want to do. Yeah. So most of the data we have in DAFNI is actually data people have brought on to DAFNI themselves for various projects and case studies. So we're not a comprehensive data repository in a sense. It tends to be project based, the information we have, or scenario based. So you'd often have to bring in external data, and certainly things like gridded weather data sets are very large, and they tend to be stored elsewhere. So that would generally come from importing data sets and uploading them to DAFNI, or using APIs to grab the data.
Yeah. And I guess that's the follows on with the question somebody's asked there about, is it more a visualization platform, or is it building the models? Which is the emphasis, or is it maybe it is both of those things?
I'd say it's more of a model hosting platform. Tom, do you see?
Yeah, I guess that's the main way it's being used. It's got good potential to expand more on the data side as well. And with the addition of Teal as well, the visualizations getting stronger. But yeah, I think collaborative model development, workflow development is a strength.
And how, I guess, in that sense, and I suppose this also follows on from that question, was there, how would people work on the same, different people work on the same model? How does that happen? So you sort of showed us those, examples. So how can that be a team of people working on the same thing? Or maybe you can.
So I glossed over that actually. But I'll bring it up and show. Let's see. So I need to reshare my screen. Okay, so if we go on here, for example, if you look at the various models, I'm gonna see. Hopefully, yeah. So you can see there it's accessed as part of the Mars group, whereas if it was accessed as a public model, it'd have a different tag up there. And basically, what this means is part of the Mars group here. So this is created to basically share and collaborate with people between different university groups and government labs, government departments. So you can see the people who are involved. This was for the development of the model. This was created, but these can be bigger, and they can be between loads and loads of people essentially.
So then all those people are able to access that model and can contribute to the development of it, I guess.
Yep.
Yeah. That's really good. Good. Well, great. I think that's sort of the end of the questions we've got. Thanks very much. I mean, it's obviously a really powerful tool that we can all make use of and access. And thank you very much for sort of introducing us to it and showing us some of the capabilities. It's really, I'm going to look, personally going to look at that, how you do the coastal flood modelling, particularly in terms of the sort of hazard exposure and vulnerability there. It's a really interesting toolkit that's available there, and see how we can make use of that. So thank you very much again.
Thank you. Thanks for having us.
Thanks.
Yes, thank you. So yes, just thank you to everybody for joining us today. And there'll be another webinar, I believe, in about a month's time, but you'll get details of that on the mailing list. And just to remind everybody again that you can sign up to be on the mailing list. If you go to our website, you'll be able to join up or email us, and the link is there on the website, so you can look at UK Coastal Resilience .org, and you will find out and be able to find out more about the network, etc., and everything else that's going on within the CoStar network. So thank you again, both to Tom and Carl, for really interesting presentations and telling us more about DAFNI and how we can make use of it. Thank you again.